pretty good.
All right, I'm in charge of baking cookies for my husband's office tomorrow. So I'm kind of looking like the mad scientist. But all right, hold on just a minute. Let me open up the quiz. I haven't even opened it up.
I haven't either. I was just gonna start that.
Okay.
Get the quantitative thing for me too. Probably be good with you because a lot of times I get confused here.
Okay. Yeah, no problem. If I look like I'm stepping away, I'm just changing out cookies, okay?
Okay. That's fine. Okay, I did. Okay, let me mark in. I prepared.
Okay, sounds good.
16 questions. Okay.
All right, let me get this. I'm learning how to share my screen with 14 different things, you know?
Oh, I imagine that's.
Okay. Well, you know, you got the someone's like, oh, you can just flip it. I'm like, okay. And then you got to size everything so you can see everything.
Yeah, that's what I'm trying to do. Get these. Everything downloaded. Open that up. Okay. Where'd it go? There it is.
Oh, man. Okay.
I don't know. Ross said he had something to do tonight, and
yeah.
Did Lily go to another group, or is she okay? Or
I actually just sent her an email.
Yeah.
Because I was like, I haven't seen her turn in anything lately. So I sent her in. She said she was out of town on a different time zone, so she hadn't been meeting with anybody. So I didn't get anything else back as far as like how long she'd be gone or
okay.
So yeah, so for right now, I guess I'm like, you can still join your group. So I'm not sure why that happens, but
okay.
All right, so this is going to be a combination of ANOVA and review questions. I'm like, first one, I'm like, what? That's a review question. That's not ANOVA. So anyway, so just tell me when you're ready. I'm ready. Like I said, I'm just going to change the cookies really quick here.
Okay.
My oven heats a little hot. Okay, so we're going to let's see. Okay.
All okay. Right. I'm as ready as I'm going to be.
All right, let's do the first one.
Okay. And ANOVA hypothesis test, we reject the HO when there is a sufficient evidence to indicate at least one mean is different from the others.
Okay, I opened the wrong quiz. I'm a dork. I was like, wait, I'm not reading that. Okay, hold on just a minute.
Okay.
Sorry, no wonder I was like, that's a review question because I was looking at the wrong test.
Oh, we are supposed to be on 14, right?
Yep.
Okay.
Yeah, no, you're totally good. It's my fault. I blew it.
Oh.
I don't know. I was looking at 14, but clicked 13.
Trying to see. So that's true.
Okay, so let me see. First question. Yes, is true. Oh, no, I completed. Yeah. Yes, that's true. Yeah, it's true. Uh-huh.
Okay.
Yeah, it's only at least one. You don't need all of them to be different, just at least one to be different.
Yeah, because I remember I wrote a little note that said one.
Mm-hmm.
So what requirements need to be checked when performing ANOVA hypothesis test? Mark all that applies. I had to write this down.
Do you have that organization sheet? Because they're also on that flow chart too.
The one you sent on the bottom of the notes this week?
Yeah, I think so. Yeah. If you look over at ANOVA and look at the second to last box, it'll say the requirements for it. But if you wrote it down too, that's totally good, but it's there too.
Okay, I'm not sure which box you're talking about. Do I need to open the lesson up?
Nope.
Okay.
It's probably something you should have potentially downloaded.
I've downloaded a lot downstairs. I'm on my husband's computer upstairs.
Oh, yeah, no big deal. Keep going. You wrote it down. So
Okay.
it was a flow chart. And it said group 1. It was that colored flow chart.
Yes, I did. I have that downstairs.
Yeah, not a big deal. If you wrote it down, we're good to go still, so it's fine.
Okay. Mark all that apply. I'm not sure. The sample means are all positive. Because you can't have a negative.
You can. Means have nothing to do with it. Your p-values can't be negative, but
Okay.
and standard deviation is never negative, but means can be negative. It's not a problem.
Okay.
We were looking at the average temperature in Siberia. The mean would be negative.
True. Okay. Data in each group are normally distributed, so that would be yes.
Correct.
And the variances are equal in each group. Yes.
Correct. And we call equal as long as there is the largest one isn't more than 4 times the value of the smallest one. We consider that equal. So it's not like they all have to be exactly 8, but we just say, hey, we consider variances equal if they are within a range of 4 times each other. So like,
Okay.
so again, so if you had 4 variances and you look at the smallest variance, as long as that smallest variance, if I multiply by 4, the largest variant wasn't be larger than that. So,
Okay.
so basically, another way to say it is the largest variance does not exceed 4 times the smallest variance.
Okay. I do remember reading that more. Okay.
And that's considered equal. So I mean, there's some. It's not like hard equals. It's like, hey, this is considered equal.
It gets confusing if you're thinking of equals.
Yes. If you're thinking in the very factual math terms, then you're like, well, that's not equal. And we're like, yeah, technically we consider that equal. If they're within that fudge area, we consider that equal.
Okay. Okay. Question number 5. To check if each group is normally distributed, do the following. Construct a scatter plot of the data, construct a histogram, construct a QQ plot for each group.
Yep. We could, the reason the B one's wrong is you could say construct a histogram for each group, and that would be true, but we don't construct a histogram for all the data. We break the data into each group and we look at each group to determine normality of each group. That makes sense? That's what makes B wrong. It's not that it's a histogram is the problem. It's that it says all data instead of each group.
So sometimes they use those words in there that you just really got to pay close attention to.
Exactly. Because you're like, well, can't I do a histogram to establish normality? Well, you can, but you would not put all the data in the pot. You would look at each group and do a histogram of that. So that's what makes B wrong. Okay.
We assume the variance in each group is the same if the following happens. So you mentioned the largest variance is less than 4 times the smallest.
Yep.
Okay. ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1 and 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples?
So do that same kind of scenario. You could go 1 and 2, 1 and 3, 1 and 4. That'd be a kind. And then you could do 2 and 3, 2 and 4, and you could do 3 and 4. So that would be all the combination of doubles you could do.
Okay, so
how many is that?
6.
Uh-huh. Yeah. Does that make sense?
Yes, it did.
Okay.
The way you said it, it made sense to me. Okay, so now I got to do the scatter shoes, soccer shoes.
And I'll just tell you right now, this quiz is super annoying because there's so much data.
Oh,
Cut and paste.
okay, I gotta find
Let me see if it.
Is this the soccer shoe ones?
Whoops, I gotta get the data too. Hold on.
Oh boy, okay.
And the worst part is the way it's organized. You can't just grab it. You got to take one group A and group B and group C and group D.
Yeah.
That came that way. Okay.
My husband's computer's so different than mine. I just have to work with it more. Oops. These. Well, I've texted, not texted, I've emailed Layla a couple times and asked her if she's okay because I haven't heard from you.
That's what I did too. I was like, "Is everything okay?" Because I haven't, she'd been doing everything, and then all of a sudden it was like, went kind of like silent, and I was like, "Is everything okay?"
Yeah, I knew she was going to be out of town, but I didn't know this long.
Yeah, I don't know. Yeah, I didn't get specific, so, but.
Oh, what happened to my graph? Hope it didn't mess up. But I'll have to start over because this stupid thing. Sometimes his is a lot different. Okay. D's.
You're ahead of me. I'm putting in the C's here.
Oh, this is weird. It's just doing all kinds of things. All right. I think I did this one downstairs. I probably had it all done downstairs.
Of course you did.
And it's just like, now start over with this one because
And it's
upstairs.
okay. All right. And
That's weird. My numbers went everywhere. Okay. Got that down. Okay. So, you have that done?
yes, I do.
So what is the minimum smallest variance for the 6 groups? Oops, I gotta spread out my sheet farther.
Yeah, you got mine now too. I had to kind of sit over there so I could see the. Okay, so what did it ask? What was the minimum variance?
Yes.
All right. So what'd you get?
Well, my thing just messed up. Hold on. My paper really went where? I got the smallest variance is 1.583.
Wait, my variances are all 27, 29, 53.
Oh, so something happened to my number 3. Okay. It was messing up on me.
Hold on just a sec. My husband's calling. Hello? Grab 2. That's probably a good idea just in case. No. Okay, let me buy. Okay.
I don't know what happened to my thing. I've lost it somewhere.
Okay. Do you want me to show you mine?
Yeah, that'd be wonderful because I lost some of my numbers.
Here you go.
Start over, clear it out.
Okay, can you see that?
Let me get my screen on. Nope, it's in a small box at the bottom for me. There it goes.
Okay, hold on. Yeah, let me make it bigger in here. So you see it? So here's my variances right here.
Yeah. Okay. If I'd quit talking, it would stay there.
That's why one of the things I like about Zoom is it'll let you just, it doesn't tell you how you have to look at it. You can pick how you want to look at it.
So it's 27.208.
Yeah, that's what I get. I guess obviously you know that 'cause since I shared my screen. You know that's what I get.
Thank you for sharing your screen since mine messed up. Largest is 53.158.
Yeah, that's right. Hello?
The test,
Green one.
the test for equal variances is satisfied for this data. I don't remember what equal variance. Oh, if it's 4 times thing, right?
Yeah, so if I took that smallest variance, that 27 point, and multiplied it by 4, it would, the largest variance would be smaller than that, basically. Does that make sense?
Mm-hmm.
So you want to make sure, yeah, which is true. If I took 27 and multiplied by 4, it would be much larger than 53. So I'm good.
Okay, so false, okay.
No, it's true.
Oh, it's true.
They're equal.
Oh, it's asking if they're equal.
Right. And they are considered equal because the smallest value times 4 is much larger than the largest variance. So, I guess, or the other way to look at it is look at question 6. The largest variance is less than 4 times the smallest variance. That's what you're looking for. So on question 8, we got 27.208. If we multiplied that by 4, that would be much larger than this 53.158. So we're good. What we don't want is our largest variance to exceed the value of 4 times our smallest.
Okay.
Does that make sense?
Yeah, it does. Just putting my head around these things. Okay. Construct a QQ plot for each of the 6 samples. Yeah.
Yeah, that's a role playing, but we'll do it. So you got to open your quantitative descriptive statistics. And you're going to have to take each data set. So it's going to take us a while. And we're going to take, so start with the group A and put that data into the QQ plot. Once you get it in there, remember you have to get it in the numbers in these are in ascending order, right? From smallest to largest.
Yeah.
And then look at that QQ plot and see if it looks pretty normal. Meaning it's linear and it follows the pattern. So for instance, let me open, I guess I got to open the other Excel spreadsheet.
I don't think I downloaded that one from on this computer.
Oh yeah, you're going to need that one.
Okay.
Whoops, why is that not open? Okay, hold on.
I downloaded the new Word 13 on this Word on this computer, and I haven't found everything in it yet. It's like,
Yeah, I use a Mac, so I I used to use a PC. When I
Well,
took school.
I have a Mac.
Oh, and but it's Word 13.
Well, mine one downstairs is a new Mac. My husband's is old, so I use the BYU site to download.
Oh, got
it.
And
I haven't figured out where he's put everything in his computer yet.
Got it.
So it's just like,
here's Group A.
So I've got to find it.
Okay, so here's mine. I can show you. Here's my Group A. See that? There's my QQ plot for Group A.
Okay.
So it's nice. It's up and down. It's very close. So that one looks really good. So now we just need to do that same process for Group B. And then import Group B. And then sort from smallest to highest. This one's not my most favorite because you got this big gap, but it's still following a fairly linear line. It's not like a so obvious pattern. It's not my favorite, but it's not horrific either.
Yeah.
So that's B. Then we just need to go through that again for C, D, E, and the socks.
So what is it? It's not the quantitative, the qualitative?
No, it's quantitative descriptive statistics.
Okay, let me put
It's
in.
the one where we build the histograms. It's the very first Excel spreadsheet we ever downloaded.
Yeah, I just didn't download it on his and descriptive. See if it pulls it up for me.
It should be, let me think. I can email it to you too. If you can't find, just tell me. I'll email it to you.
Yeah, I've only found when I'm on the quantitative inference.
Okay, let me get this email to you. Just a sec.
Descriptive.
I can't remember where. We probably got it in by lesson 2 or 3, I would think. Really early.
Yeah, and I do have it downstairs.
I'm sure. Okay, let me just get it emailed to you. Hold on. Okay, let me see here.
Sure, I'll look too.
I'm just gonna reply to your Google email and attach it, okay?
Okay. So is this exam easier, hard, the same amount as the first exam, or what'd you say?
In some ways, I think it's easier because you've seen a test before. You're kind of a little bit more familiar with the way they ask questions. You know, some of the okay, I just sent it to you. Some of the things are just a little bit more familiar to you. But what people tend to have a harder time. What challenge on this one is is trying to determine, is it, you know, one sample Z-test, one sample T-test, you know, 2 sample match pairs, 2 sample independent study, or independent study, well, independent samples. So, you know, it's about, it's trying to, you know, determine those kind of things that I think can be trickier. So you kind of, it's one I think you just need to go slow and be methodical. I mean, like, read the information. You need to key off. There's some contextual clues. And I just did a couple reviews today that you can watch, but it's, and I am talking about what are the contextual cues. And for one of them, it's like, if you're given sigma, it is a 1 sample Z-test, because that is the only situation in which we are given the value of the population standard deviation. So, you know, you want to look for those contextual clues. If it's 1 sample and we don't know sigma, then it's a t-test. That's all it can be. And then, you know, and then there's a couple clues for trying to determine whether it's 1 sample or 2 sample match pairs or 2 sample independent groups. So I think those can be a little bit challenging. You have to be very comfortable with that idea of if you reject the null hypothesis, then you're saying you have sufficient evidence for the alternative. And if you fail to reject, you have insufficient. You need to be able to understand what a type 1 and a type 2 error is and the relationship between them. You know, so it's got a lot of stuff like that. But I go through all of it on the I did in 2 parts, 2 30-minute videos. And so I go through all of, you know, example and information on all of it. So I'd say if you're comfortable with everything that I put on the review, then you should be okay. Okay. Yeah, and use your notes. Use your notes to do a couple things. Write definitions. Actually do some sample problems on your note page. You know, like if you're like, I never do these percentile ranking questions right. As you're watching the video, you go, man, that's always one I mess up on. Then copy it down, you know, step by step, so you can look at it when you're taking the test. Yeah, I've been slowly doing. I'm gonna have to write really small to have my one sheet. Yeah. Well, you can have that organization sheet too. So. Oh, I can. Okay. Yeah. So, and that, if you can understand it, that's super helpful. Okay, I got that. I just downloaded that plot now. Okay. This Word 13 is kind of nice. Is that? Yeah, it is. I mean, it. When you print it, when you do everything, it's really cool. Okay, so you showed me 2 of them. Is that right? I did A and B. See, I'll have you do C next ones, but make sure you're comfortable with that. Okay. Let's see. Q plot. Paste. And then they gotta sort. Yeah. Sort by smallest to largest. There we go. Yep, that one is similar to the first one that you showed me. It's really pretty good on the line. Good. Okay, so then we'll go to the next one. Okay. So they're just really having you practice this whole QQ plot, you know, being comfortable with what, and then what is the purpose of the QQ plot? And you have to remember, we need to establish normality to use both the Z distribution and the T distribution and ANOVA. So we can be told the population, each population of interest is normal, which like never happens on ANOVA. Or in the case of ANOVA, we don't use central limit theorem. So you've got to do a QQ plot. And you've got to look at the data in the QQ plot. And if the data in the QQ plot seems to follow a linear formation, then we're very comfortable saying, hey, this data must have come from a normal population.
Okay, so that one looks just similar too.
Okay, good.
So this is,
These are not big data sets, so there's gonna, they're not gonna be perfect. The more data you have, the easier it is to look at QQ plots. You don't get these as big a break. If it's a big break and it's a lot of data, you're like questioning it. But when there's not much data, it's just naturally going to have a little bit of breakage in it.
yeah.
But you just don't want to be looking at like an S, curvy and, or everything down and everything up.
They can get confusing.
Yeah.
Okay, now I'm just doing the sock one.
Okay.
They all look pretty similar.
Perfect. Okay, so that's really all they're asking you to do on that quiz question is just kind of feel comfortable with looking at QQ plots.
Okay.
So so we're on, let's see. And then it's just saying, so each of the samples are approximately normal based on what you saw in it. And if you, since we looked at them all and they look pretty linear, then the answer to that is just true.
Okay. So perform a ANOVA test in SPS and observe that the p-value is 0.081. Then remove the sock data and perform the test again. What is the p-value when we remove the sock data?
Okay, so what did you get for your p-value before with the sock? Just so I verify mine with yours.
My thing was messing up. Hold on, let me see. Because I didn't get that one in there. I got it in there wrong.
Okay.
I'm gonna have to redo this. Because I lost 3. Whoa, that's weird. I lost 3 of the data, so I got to go back. I don't know what happened. Okay, let me start quantitative again. So I have to bring it up again and redo the whole thing.
Okay.
Because this is messed
Not
up.
bad practice.
Yeah, I didn't want practice. I love practice.
There you go.
Okay.
On the biggest data set we've ever had, right?
Yeah. Let's see. All right, come on, give it to me, please. There we go. Oh, hopefully this one will work. Let me minimize so I can see a little of you. Okay, let me start again.
Okay.
Thanks for being patient with me.
No problem. Sorry, I'm making noise over here.
No, I know. If I could smell them, that'd be even get better. Yeah.
It's the classic. My husband calls at 3 o'clock and it's like, oh, by the way, our office is having a potluck and I'm supposed to bring cookies. I'm like, oh, good to know. Which it means not he needs to bring cookies. It means I need to bake cookies so he can bring cookies.
Yes, it does.
It had to be pumpkin. That was it. It's all, because tomorrow's Halloween. It's like, it needs to be pumpkin cookies.
Oh, yeah? Pumpkin cookie. Do you have a favorite recipe you use?
Well, I actually had one I really liked, and my daughter sent me one just like a week ago and said, that it's all the rage in their neighborhood, this one recipe. So I am I'm testing it to see if I like it as much as the other one. We'll see.
You like pumpkin a lot in your family?
Yeah, I mean, I don't know that it's like the ultimate all-time favorite of everybody's, but I think everybody likes it. My daughter really likes pumpkin. She loves pumpkin and peanut butter stuff. It's got pumpkin or peanut butter, she's in.
Yeah.
Who are you talking
I'm out working.
to? Oh, well, there you go.
There you go. I gotta find my earbuds and then I won't bug you, but I'm not sure where they are right now.
Okay.
Anybody left them? Mine left them in trouble.
Is that the kind?
It's
No.
fine. No, it's fine.
What was I supposed to get?
The green one.
Oh, I got this one.
Okay, good.
I blew that. Sorry about that.
Sorry.
Okay, I got it now.
Okay, good.
The p-value is 0.0809.
Okay, perfect. All right, good. I just want to make sure we had the same.
Then it's asking me to take the socks out. Okay.
Okay.
You want this removed? Probably not.
So 0.309.
Okay, hold on. Where's right? 0.309. Yeah. Okay. Yep. That's what I got.
Okay. At least it worked this time for me.
Yeah.
The test statistic for NOVA hypothesis test is an F statistic. Is the p-value the area to the right or left? The reading always said to the right.
Correct. Correct. That's always the case. It is a right skewed distribution, and you only shade to the right.
So is there like a graph that you do with that or not?
If you want to see what it looks like on the announcements, on the announcement page, I have a picture of an F statistic.
And in the reading it said mark it, so I didn't know if I had to find one to mark one or what.
No, you don't. But basically just know that it is right skewed. So that's why it's never two-tailed. It's we don't know. Notice we didn't pick if it's one-tailed or two-tailed test. It's always just going to be your test statistic will always have you shading on the right.
Okay.
It's the only option.
All right, I think we're in the hot dogs. All right. So the hot dog research. Let's examine the calories first. Okay, I gotta put it in the.
Okay, let's see. Yep, the one of the bigger pains is now not only do we have to put in the hot dog, we have to also delete the other columns that we're not using. So we're doing which one? Let me read it. We are doing calories. Okay. Just want to make sure I grab the right thing here.
Calories. Okay.
Calories. So we got beef.
Oh, I see. Okay. Just thinking, what am I doing here? Beef? Okay.
Yeah. Beef, and then we're gonna do meat. I don't know what that means.
I'm hoping it's the same.
It's like a mix, I guess, of different meats. I don't know.
I don't want one of those hot dogs.
I was expecting it to say pork. Then make sure you delete that extra data for you.
Okay.
And then poultry.
And
make sure you only have 3 columns of data, so you get rid of that D and E from the previous question.
Okay. All right. Okay, so the question, then I have to do a QQ plot, right?
Oh, is that what they asked us right away? Okay, I'm like, we just put it in all the.
Oh, it's just, we're gonna do calories first. Oh, that means I'm doing the other one too, okay.
All right. Okay, so it says okay, so we have to make sure the assumptions are met. So there's really a couple things. One, randomization. That, and they let us know that for each analyze, they recorded type. And then we need to, besides randomization, there's those 3 things. Besides randomization, the other thing we have to do is to make sure that each of them are normally distributed. And the third is we have to make sure that the largest variance does not exceed 4 times the smallest. So we can do that one first. You can look at that output table. And here are our variances. Do you have those?
Yeah, the 512 is first one, 636 and 508.
So if we took 508, multiplied it by 4, that is definitely bigger than the variance, the biggest variance, which is 636.846. So we're good to say they're equal. So that one we can check off as well.
Which one was that one you were looking at?
That is, it's asking us if the assumptions, that question 14, let's examine the calories first, construct QQ plots of the calories for each of these 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. So I just said, let's just look at the variances first since we put it into the ANOVA. And so I just was looking at that one first.
It says that each one of them says the variances are equal. You just have to read through each one. Hold on. Oh, so you're saying that part of that sentence is that. Okay.
I was just saying, hey, well, let's look at that variant. The variance is equal. So by definition, the variances are equal if the largest one does not exceed 4 times the smallest one.
Okay.
And so since we're already on that ANOVA spreadsheet, I just figured we'd look at that first.
Okay.
So the smallest one is 508.566. And obviously, if I multiply that by 4, that is a much bigger number than 636.
Right. Okay.
Therefore, that assumption has been met. We're good. We can say the variances are equal. It's met that test.
Okay.
So now we need to go do the QQ plots.
Okay, even though there's only one that says the assumption have been met, all the rest of say have not been met.
Well, we got to make sure they've been met.
Okay.
So we
don't assume anything is what you're saying.
Yeah, don't assume anything.
Okay. All right.
So go to your quantitative descriptive statistics. Wherever mine is, there it is. Found it finally.
There's just so many things. I think you need like a dozen screens.
It's partly because we're dealing with Excel, which is not a statistical software. And so it's just not, like if we use, and you'll see it referenced in their SPSS, it knows if you're doing ANOVA, you need to check the QQ plots. So it'll automatically have, you know, when you're on an ANOVA sheet, it'll automatically have the QQ plots for you right below the data for each set.
Oh, really?
Yeah. But it's this, anyway, they had a BYU, I had a license for a while, but it just was expensive and it was a little bit cumbersome and some, you know, and it crashed a couple times. One time during a test, during, you know, a test week. So,
wow.
So they just kind of decided that they would just stick with, just have everybody use Excel. So, but Excel has its limits. It's just problem with Excel, but so yeah, so there's certain things that are just super cumbersome on Excel that would be easier if we were using statistical software.
Okay.
So yeah, so like you're doing this and you're like, holy Toledo. I mean, first semester I thought, I was like, really? I have to do this every time? So I'm like, yo. So, but but I guess I'm like, well, I guess it's good practice to, just go through, look at it, run through the process.
Yeah. Well, I like Excel. I just would like to understand it better.
Yeah, no, it's good. It's just more of a businessman software than a statistical software.
Well, when I did the QQ plots, they all look pretty normal. Just the second one was a little bit bigger, but nothing major.
Nothing glaring. Okay, so then we can pick that the assumptions have been met. Because we checked the QQ plots and we also checked the variances. So we've done both those things.
Okay.
And we're comfortable with all of that.
Yeah, wonderful. Run a ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51.
Mm-hmm. You got that? It says between groups, and there's a 2, and then within groups, and there's a 51. See
yes,
that?
I see that.
Okay, so those are your 2 degrees of freedom.
And then F is 16.074.
Which means that we're talking about being 16 standard deviations away from the bulk of that F statistic. So you're out on that tail 16 standard deviations away from 0, basically.
Oh, wow, okay.
So it's way out there. So note the p-value is 3.86 e to the negative 0.06, which means move that decimal point left 6 spots.
Oh, wow, okay.
So that means you'd have a p-value of 0.0000386. So to 3 decimal places, you'd have a p-value of 0.
Right, I see that, okay.
Okay, so that's what they're telling you in question 15. So if you have a p-value of essentially 0, it's not equal to exactly 0, but essentially 0 to those 2 decimal places, are you going to reject or fail to reject?
So 0 is smaller than the 0.5, so we're going to reject.
Okay, so if we reject, then we say we have sufficient evidence for the alternative.
So reject. We have sufficient. So it's the first one. We have sufficient to claim. We have sufficient evidence. Okay.
It's not the first one because the first one that's the HO. All 3 hot dogs have the same mean number of calories. That's the HO, and we don't make our conclusion in terms of the null hypothesis. We make it in terms of the alternative. So we've rejected the fact that all 3 hot dogs have the same mean number of calories. That was the null hypothesis. And since we rejected that, we have sufficient evidence for the alternative. So what's the alternative? What's the wording of the alternative for an ANOVA test?
At least one.
Okay.
It's going to have a different mean, right?
So now go through.
So it's the bottom one. We have sufficient evidence to claim that at least one of the hot dogs.
Good. That's exactly right.
It's probably good you were meant to be here so that I could get this better. Oh boy. I said to my husband, now I'm going to have to do every one. Normally I just have to do some of them. This is good. I appreciate this a lot.
No problem.
Number 16. Now let's examine the sodium levels.
Okay, so now we're going to go through that same process again. We got to look at the QQ plots, and we have to look at the variances.
Find my hot dog thing again. There it is. Sodium. I work at Sam's Club, so these are like really high. Some of them,
Oh
these
my
ones
gosh.
are pretty good.
Yeah, no kidding, right? Like, oh my goodness. You knew how much salt you were intaking, huh?
Yep, it's bad.
Part of the reason they taste good, but
It is. I agree totally. Okay. We all get accustomed to all that sugar and salt anyway.
yeah.
And last one. My husband took, when he was in college, he took calculus and all that. And
Mhm.
he said he did some of this stuff. And I said, I don't know how you did it by hand. 'Cause I said I wouldn't have lasted.
It
You're
was
done.
not easy.
Yeah.
It was not easy.
So you had to do it by hand too, huh?
Oh, absolutely, yeah.
Oh, yuck. Okay, so doing the same, seeing if it's the assumptions have been met or not.
Okay.
So
Yeah.
the variances,
Uh-huh.
I have 1,040, 10,492, 8,
Mhm.
12, 8812.
Okay, so the smallest one is 7180, basically, right?
Yeah.
And if I multiply 7,180 by 4, that would be far larger than the largest variance of 10,492.
Right.
So we're good.
So they have been met again.
Well, that part has. Did you do the QQ plots?
No, I'm going to do that next. I was just seeing.
Okay. Yeah, the variance requirement has been met.
Okay.
So now we need to look at I just did them. I'm not a huge fan of the poultry one. It's a little bothersome. To me, but you tell me what you think.
Well, I just did the beef one.
Yeah, the beef one looked fine to me.
Yeah.
And the meat one looked pretty good, but the poultry one, tell me what you think.
Almost looks like the, let's see. Okay. Copy the poultry. Got to delete the bottom 3.
Yeah.
Well, I see it looks similar to the other. For me, the first one doesn't. Yours not. Yours doesn't.
No, let me show you what mine looks like.
Maybe mine is. Maybe I copied the wrong.
Well, maybe not, but let me just show you what mine looks like, and you tell me if it looks like. Where I gotta find it? Here it is. Okay. Oh, I have to share my screen. Hold on. Okay, let's see.
Oh, I see. Mine went twice with the same numbers. Okay, that's why.
So mine has this. See, it goes all up, then a break, then down. So it's not my favorite because it's like there's this pattern. It's like getting, it's going up, 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 then dropping down, then going below, then staying below, and then building back up. So it's a little bit of a pattern. It's not my favorite. So, but you tell me how you want to answer question 16.
I was just, for some reason, it won't let me paste in the right one. So the assumptions have been met.
Okay. So if you feel like that QQ plot is okay, you're okay with the poultry one, then yes, the assumptions have been met because we checked the variances already. So,
So is the variances the more important than the QQ plot?
nope. No, they're equally important.
They're both, okay.
Mhm. So which one do you want to?
I'm going to go with the first one. The assumptions
Okay.
have been met.
Okay, that's
It's okay to assume each group.
okay. That's fine. Okay, and let's go down to question 17.
So I may not got that one right the way you're kind of answering.
No, I think it is. I think it's one of those ones where you could go either way. You could go with A or you could go with C, and I think either way you could justify it. So I think you're okay either way.
Okay.
The poultry one, it has just enough of a pattern. It's not glaring, but it's enough of a pattern. It might be a little bit of a red flag, but I think they'll accept either one because it's not glaring. So I think you're fine with A.
Okay. Despite the possible problem with the QQ plot for poultry, you decide the no determine if the mean sodium levels are the same for all three groups. What is the p-value for this test?
Okay.
I don't know what happened, but my meat and my poultry went to all the same numbers
What?
on my
On your ANOVA test?
now on the Excel when I loaded it down when I downloaded it.
Oh, that's interesting. So so do you have them on the ANOVA test? They're all the same.
Well, I'll tell you what my the p-value, and I know it's wrong because both the group 2 and group 3 are exactly the same numbers.
Yeah, that's
Just
not right.
noticed that.
Here, I'll share my screen with you. You can look at mine.
So I know my p-value is off.
Yeah, it's definitely gonna be off. Okay, here's what I have.
If I learned how to undo this, I can figure it out.
Okay, so here's the p-value I have.
Yeah, it's a lot different. Yes.
Yeah,
Zero-
it's going. Yeah, you don't have the right data, and you're definitely not gonna have the right p-value.
So 0.179.
Yeah, that's what I have.
Okay. So I got the last questions. All right. What conclusion can you draw about the mean sodium level of the three types of hot dogs? Not
Okay.
the hot dogs, right?
All right. So first thing I always do when I answer these questions is I say to myself, would I reject or fail to reject? So you got a p-value of 0.179 and your significant level is 0.05. So are you going to reject or fail to reject?
It's where I get always confused. So I fail to reject.
Okay, so if I fail to reject, then I say there is not sufficient evidence for the alternative.
So insufficient evidence.
So right away, you need to disregard any multiple choice that say there's sufficient evidence, because we're saying there's not sufficient evidence or insufficient evidence. So right away, you can get rid of, wow, okay.
They're wording this different.
Yeah, but it's still insufficient is to say you do not have sufficient evidence.
Well, so they made that one easier because there's only one do not.
Mm-hmm.
So they switched it from last week to insufficient. Now it's do not.
They usually almost always say insufficient, so I'm not really sure why they changed the wording on this.
Just want to confuse sometimes. It confuses me. Sometimes the way the words go confuse.
Well, you know why? Because this actually isn't a conclusion. This is kind of actually about, it's really not, it's a little bit odd because it's not really a conclusion because it's really the decision. It says that they say we do not have sufficient evidence to reject the claim. So it's really, so it's a little bit, actually, it's kind of like, it's a little bit of an odd way of wording it.
Yeah.
Which is true. We're failing to reject, so we do not have sufficient evidence to reject.
Right. Okay.
Yeah.
All right. Now I can just submit that because you helped me through that.
Hopefully it was helpful. Hopefully it helped you understand.
It did help me.
Okay.
Because, and you being patient with me and being able to work through with me.
No problem.
Because sometimes I just need to go through it slower. And, when I do it with everyone, You know, they know what they're doing a little faster than I do. It's like, wait a minute.
Yeah, you're like, hold on. Okay, we didn't double check that I'd heard all your answers, but did you already submit?
I did.
Okay. How'd we do?
We got them all right.
Oh, okay. All right.
Yeah, it says 20 out of 20.
Nice. Good job.
Well, that was with your help. Thank you very much.
You did all the work. I just directed you where to go. That's it. So yeah, that's good. Just those are good things to think about, the QQ plot and the variance. Make sure you understand those requirements, because they like to ask questions about that. Because again, they're like, what's the p-value? They know on a test, you're just reading it off an Excel spreadsheet. So they're going to ask you, like, are the assumptions met? Which is more of a question you can't just cut and paste from an Excel spreadsheet. You have to go, oh, I looked at a QQ plot and I looked at the variances, and the smallest variance was this and the largest was this. Therefore, I know they're considered equal. So those are more the type of questions they like to ask, because it requires you to think, not just basically spit out, copy and paste an answer from an Excel spreadsheet.
Okay. That helps me with knowing more what to study for too.
Yeah. I mean, they will ask you for a p-value, but you just need to know they're going to ask you for questions that are not just merely off an output table. So.
Thank you. It's a nice chair you have there.
Oh, thanks.
It's cute.
Thanks. All right. Well, let me know if you have any other questions.
I will. Thank you very much.
All right. Take care. Have a good night.
You too.
Bye-bye.